Hello, in this video we are going to explore the PriorGen package. It has three functions, the find beta, the find beta QQ, and the find beta MUPC. Let's see how they work. The PriorGen package can be used to translate beliefs into priors in the form of beta and gamma distributions. And the motivation to create it came from the need to easily generate priors for disease prevalence and the sensitivity and the specificity of diagnostic tests. But of course it can be used for any proportion. You may download it from CRAN, this is the link. Let's see next a few examples for each of the functions. We are going to start with the find beta function. For the find beta function, the users are asked first to specify their prior belief about the mean, or the median, or the mode. Then they should also specify their expectation about the value of a specific percentile, usually the 95th percentile, which is also the default for this function. Let's see an example. Assume that you're expecting the mean for the sensitivity of a diagnostic test to be 0.90. Right here, so the mean is 0.90. You don't need to specify a value for the median or the mode. You have specified for the mean. And you're also 95% certain, okay, so the percentile value is the default one, 0.95. So you are 95% certain that it is not lower than, right? This is not lower than, so lower value is F, which stands for false. It's not lower than 0.80. So the percentile value corresponding to the 95th percentile is 0.80. This is how the find beta function looks in this case. Try it in R and see which beta distribution corresponds to these specifications. Let's see another example. Assume that you're expecting the prevalence of a disease most likely to be 0.15. So this means that the mode is 0.15, and since you have specified the mode, you don't need to specify the median or the mean. Alright? And you're also 90% certain, so the percentile value now is not the default, it's 0.90. So you're 90% sure that it is lower, which means that now lower value is true. It is lower than 0.40. So the percentile value is 0.40, right? This is how the find beta function looks in this case. Again, try it in R and see which beta you can get. For the find beta QQ function, you can find a beta distribution based on your beliefs about the values of two percentiles. Let's see an example. Suppose that you're expecting 20% of the units in a region to have a disease prevalence less or equal to 0.30. So percentile value 1 is 0.30, corresponding to the 20th percentile, right? This is here, and this is here. And you're also 90% certain, so percentile, the second percentile is 0.90. So you are 90% certain that the prevalence is less than 60. So percentile value 2 is 0.60. Again, this is how the find beta QQ function looks in our case. Try it in R and see what you get out of it.